You're sitting by the airplane window. The engines start getting louder. The plane slowly begins to move. At first, it feels heavy, slow, almost reluctant. Then it reaches the runway. The engines roar. The aircraft accelerates faster and faster. Buildings start to blur outside the window. The pressure pushes you gently into your seat. And then something strange happens. Without any visible wings flapping, without any giant push from the ground, this enormous machine, weighing tens or even hundreds of tons, simply lifts off. The ground shrinks beneath you. Cars become tiny dots, and suddenly you're floating 35,000 feet above the earth, which raises a question that almost everyone has wondered at some point. How can something this heavy actually stay in the air? Before we dive into the answer, take a quick second to subscribe to the channel and leave a like. It really helps the channel grow and lets us keep making videos that explain the everyday things most people never stop to question. Now back to the mystery. Because at first glance, airplanes almost seem to violate common sense. Think about it. If you drop a rock, it falls immediately. If you throw a car into the air, it crashes right back down. Gravity pulls everything toward the ground, and airplanes are incredibly heavy. A fully loaded commercial jet like the Boeing 737 weighs around 80,000 kilograms. Larger aircraft like the Boeing 777 can exceed 300,000 kilograms when fully loaded. That's hundreds of tons. So why doesn't gravity just pull them straight back down? The surprising truth is that airplanes don't defeat gravity, they simply balance it. To understand how this works, you have to realize something important about the air around you. Even though it feels invisible and light, the air surrounding the Earth is actually a massive ocean of gas. It has weight, it has pressure, and most importantly, it can push on things. Right now, as you sit there watching this video, the air around you is pressing on your body from every direction. You just don't feel it because the pressure is balanced. But airplanes are designed to take advantage of this invisible ocean. The wings of an aircraft are not flat pieces of metal. They're carefully shaped structures designed to interact with the air flowing around them. This shape is called an airfoil, and it's the key to everything. When an airplane moves forward at high speed, air begins flowing around its wings. Some of that air travels over the top of the wing, some travels underneath. And this is where something fascinating happens. The air moving over the top of the wing actually speeds up. The air moving underneath moves slightly slower. Now here's the crucial part. When air moves faster, its pressure drops. When air moves slower, its pressure stays higher. This creates a difference in pressure between the top and the bottom of the wing. Higher pressure below, lower pressure above. And pressure always pushes from high to low, so the air underneath the wing begins pushing the wing upward. This force is called lift, and lift is what allows airplanes to rise into the sky. But here's what surprises most people. Lift isn't something that suddenly appears when the plane leaves the ground. It's building the entire time the aircraft is accelerating down the runway. As the plane moves faster, more air flows over the wings. The pressure difference grows stronger, and the upward force keeps increasing. At first, it's not enough to overcome gravity, but eventually, lift becomes equal to the plane's weight, and at that exact moment, the airplane becomes light enough to leave the ground, not because gravity disappeared, but because another force finally matched it. And once lift becomes stronger than gravity, the plane climbs. But this explanation still leaves a big question unanswered. If wings simply create pressure differences, why can't any fast-moving object fly? Why doesn't a speeding train suddenly lift off? Why doesn't a car on the highway start floating? Because there's another piece of the puzzle most people don't realize, and it has to do with how wings interact with the air in a much deeper way than it first appears. In fact, the real explanation involves something even more powerful than pressure alone. And once you see it,
airplane flight suddenly becomes much easier to understand.
The missing piece of the puzzle is something called downwash. And once you understand this, airplane flight suddenly becomes much easier to picture. When a plane moves through the air, the wings aren't just creating a pressure difference. They are also doing something else at the same time. They are pushing air downward. A lot of air. Think of it like this. Air might feel light and invisible, but it still has mass. And whenever you push mass in one direction, physics says something must push back in the opposite direction. This is actually one of the most fundamental laws of motion. For every action, there is an equal and opposite reaction. So when a wing deflects huge amounts of air downward, the air pushes the wing upward, and that upward push is lift. In other words, airplanes fly because their wings continuously push air toward the ground, and the ground never even has to be nearby. Even when a plane is cruising 10 kilometers above the Earth, its wings are still throwing air downward behind it. If you could see the airflow behind a flying aircraft, it would look like a massive stream of air slowly bending downward. This effect is powerful. A large passenger jet can push hundreds of tons of air downward every second while flying, and that constant downward momentum keeps the aircraft supported in the sky. This is where most people get confused. They imagine the plane somehow sitting on the air, like a boat floating on water. But that's not really what's happening. A boat floats because water physically holds it up. An airplane stays in the air because it is constantly moving forward and redirecting air downward. If the plane stopped moving forward, the wings would stop pushing air down, and the lift would disappear almost immediately. That's why airplanes need speed to fly, and that's exactly why runways exist. The runway gives the plane enough distance to accelerate until the wings are moving fast enough through the air to generate sufficient lift. But even after takeoff, speed is still essential. Every aircraft has something called a stall speed. This is the minimum speed required to keep enough air flowing over the wings. If the plane slows below this speed, the wings can no longer push enough air downward. Lift drops, and the aircraft begins to fall. That's why pilots carefully manage speed during flight, especially when landing. During landing, planes slow down dramatically. To compensate, pilots extend flaps on the wings. These flaps increase the wing's surface area and allow it to push more air downward, even at lower speeds, which means the plane can stay airborne long enough to land safely. Now here's something even more interesting. The engines of an airplane are not what keep it in the air. This surprises a lot of people. Engines produce thrust, which pushes the airplane forward, but it's the wings that create lift. In fact, a modern jet can still glide for a long distance even if the engines stop. That's because as long as the aircraft keeps moving through the air, the wings continue generating lift. The engines simply make sure the plane keeps moving fast enough. So when you look at an airplane flying overhead, what you're really seeing is a machine perfectly balancing four forces: lift pulling upward, gravity pulling downward, thrust pushing forward, and drag pulling backward. As long as these forces stay balanced, the plane continues flying smoothly through the sky. Which means that enormous aircraft you see crossing the clouds, a machine weighing hundreds of tons, isn't defying physics at all. It's actually following the rules of physics with incredible precision. And once you understand that airplanes are really just machines designed to push air downward while moving forward, their ability to fly suddenly stops feeling like magic. It starts to feel like brilliant engineering. Because sometimes the simplest things hide the most misunderstood truths.